This is an example of a two-sample t-test. So I would recommend pausing the video and read through the paragraph and the question, and then we can go from there. So hopefully you've read it and you see that we're studying cholesterol. Looks like we are comparing a standard drug and a new drug right there. So there were 100 people with cholesterol levels available, with high cholesterol levels available, and they did random assignment. So they talk about that right there. So 50 people went to each of the two treatment groups, and they give us all the statistics. We see the mean, we see standard deviation for each. So let's go ahead and dive into our state plan do conclude. So I would recommend giving each section a try before I write it. So I'm going to dive into state. So maybe hit pause before I start writing. All right, we are talking about people with cholesterol between 250 and 300. So I just don't want to write that twice because we're about to define the two groups, and that's true of both groups. So the true mean for group 1 we're looking at, they made it nice for us so we don't have to worry about negatives or whatever like that, or going down is better. So they just listed out the true mean decrease. So that's going to be a little bit easier to work with. And they defined that right there, and then again right there. So that's how I know what we're talking about. True mean decrease in cholesterol. I'm going to abbreviate a little bit for standard cholesterol lowering. I guess I'll spell that out. Medication. And then group 2 is the new. True mean decrease in cholesterol for new cholesterol lowering medication. So some repetition there. This is a hypothesis test, not a confidence interval. So we're going to set up two hypotheses. So the null is we assume the two means are the same. And in that question right here, it tells us we're testing if the new drug is more, and mu2 is more. Or I'm sorry, is new. I said that wrong. So we are suspecting that mu2 is larger. And one more thing to add. Let's say alpha is 0.05. It is up to you. You can let it be 0.05, 0.01, 0.1. I wouldn't pick an alpha anything larger than 0.1, but 0.05 is the standard. So let's move to the plan step. Hope I have enough room. I was writing kind of big there. They were randomly assigned to each of 2 treatment groups. So let's say that. You have to skim through the paragraph anytime you have this and find how they applied randomness. So random assignment to treatments. And we're also in luck because the 2 sample sizes are large. So take a moment. What are they larger than? What's the magic number for means? We like them to be larger than 30. If they were not larger than 30, we couldn't proceed. Sometimes if that happens, they'll give you data, and then you can make graphs and approximate to normal distribution. But we didn't have data, and sure enough, we had sample sizes big enough, so we were good. Usually it's one of those 2 scenarios. Either it's big enough, it's over 30, or they'll give you a list of data. If it is smaller than 30, then you have to make a graph and talk about it. But these are greater than 30, so we know the sampling distribution is approximately normal. All right, let's move to the do step. We checked randomness and sample size. So name the test, and we are doing a 2-sample t-test. One way to determine that, it gets kind of tricky when you're first learning this, but remember on your calculator, if you're using your 84, you press stat, go right to tests. You have many tests to choose from. So, I mean, you know we have 2 samples. So whenever you click that, you have 3 different tests to choose from that have 2 samples. Hopefully you know it's not Z, a 2-sample Z-test. Remember, we don't use Z, a plain old 2-sample Z-test, because we do not know sigma. This right here and this right here, those are the sample standard deviations which cause us to use T. If those had been sigma, then we would have used Z. But the reason why we use T is because we do not know the population standard deviation, we only know the sample standard deviation. And that's usually always the case. So usually if we're talking means and 2 groups, it's gonna be a 2-sample t-test. So jump to your calculator and type in all the data. Maybe write it down right here so you have it all nice and organized for yourself. So we had 10 for group 1. Units are nice, but not necessarily vital. Group 2 had a mean of 18. And type it all in to a 2-sample t-test. We don't have data, we have stats, so click stats. If you're using a TI Nspire, on a blank screen, hit menu, statistics, and tests. I think it's hypothesis tests. And we want 2-sample t-test. And type it all in. Oh, on that calculator, it asks you right away, do you want data or stats? And we have stats in this case. So get your results. And T should be negative 3.9223 with 85.4 degrees of freedom. And then it gives a p-value that looks like this. It just says P, and it says 8.8357, maybe a few more numbers, and then E to the negative 5. I would not write it that way. I would write it one of two ways. You can write it like this. Remember, to the negative 5, that's in scientific notation. Move the decimal 5 times to the left. So that means we have 4 zeros. My computer screen just went blank. Hopefully it didn't go blank on the video. So something like that. Or anytime I have more than 3 zeros, I just say it's about 0. And that's the p-value. So anytime I see negative 5 or smaller, I just write it's about 0. And that's the p-value. Inspire's nice because it says literally p-value on the screen versus just plain old p. Oops, I deleted some of my stuff there. So I like to write it like this. You can just say p-value equals 0, or I like to write it the proportion way. It's up to you. That's about 0. Some people are struggling with what to do at this point. That p-value, that number, that 0, is what we've been working for this whole problem. And that's going to help us make our conclusion. Is that 0 significant? So I'm going to compare that number, we use a different color here, this number with alpha. So alpha is my significance level. That's how that helps me make my decision on whether or not I reject the null or fail to reject. So I like to write it like this. P is less than alpha. And of course, if that proportion had been larger than 0.05, I would have flipped that inequality. So the p-value is smaller than alpha. That causes me to reject. So move to conclude, and we're done. Reject HO. Evidence suggests the true mean decrease in cholesterol. Make sure you use context here. Is more for the new medication than standard. And just to make sure I answer their question, the new medication appears to be more effective. I hope that helps. Let me know if you have questions.